Good morning, students. So this class is for the students of first semester B courses of all branches under VTU. So this year you have the new syllabus. For every 4 years once, university revised the syllabus. So this year also it is revised. So the subject code is here 14MAT11. Here 14 represent the year in which the syllabus is revised. So this year you have the new syllabus. Math represent mathematics. 11 means the first semester, first subject. So if it is 12 implies 12 means first semester, second subject, like that. It is the first subject in the first semester. That is Engineering Mathematics 1. So as I told, this year you have the new syllabus. The entire syllabus is divided into 5 modules or 5 units. In the exam, in every unit, 2 questions will be asked. Students are asked to write any 5 questions, choosing one from, it is multiplication, it is addition to the elements of, any row by, it may be column also, any row or column by the corresponding elements, of any other row or column, other row which is multiplied by a scalar, which is multiplied by a scalar. So that is the third operation. So what this means take any row or column, suppose that ith row. Suppose that we are replacing this one by, that means this symbol used, that means ith row is replaced by, how you replace? You add the elements, that means addition to the elements of any row, that means addition to the elements of ith row by the corresponding elements of any other row, suppose that jth row, which is multiplied by a scalar. It is actually multiplied by a scalar. So let it be k times rj plus ri. That is the row, that is ith row is replaced by this sum. So this is another operation. So these 3 operations are called elementary transformations or elementary operations on a matrix. So only these 3 operations you have to perform. So using this operation, suppose that any one of the operations applied on a given matrix, we get a new matrix. So that matrix obtained, new matrix obtained, it is called equivalent matrix. So that is equivalent to the given first matrix. So what is the change? Only any one row or column is changed. How it is changed? By applying any one of the operations. So a matrix obtained from the given matrix by applying any one of the elementary operations is called an equivalent matrix. But you have to note that for a given matrix and its equivalent matrix, ranks are always equal because no change in the rank. Rank means how many independent rows are there, that you have to check. So you apply this type of operations, it does not change that property, that dependence or independence. So if you want to find the rank of a matrix, if you apply this type of operations, does not affect the rank of the given matrix. So when it is asked to find the rank of a matrix, how to find means you have to apply these operations and there you have to count how many independent rows are there. So that procedure is equal to or equivalent to. So whenever it is equivalent, we use this symbol also. Suppose this A is the given matrix. We get this matrix B from A by applying any one of the operations mentioned here. Then this matrix is called equivalent to A, and we write like this, the symbol used. When it's, suppose these are the elements of this matrix. You have to get the rank of this matrix. As I told, you can guess what may be the answer because how many independent rows are there? These 2 are independent. The third row is nothing but it is obtained by multiplying the first row by 2. And last row, it is obtained by multiplying the first row by 3. So you may see that these 2 are dependent rows. First two are independent rows. So here number of independent rows 2. So rank of this matrix 2. In advance you can understand what is that. But if it is asked for 5 marks, not simply writing the answer is 2, we have to show the steps. For that we shall reduce this into upper triangle form as per this rule. Then see how many non-zero rows, that will give the rank of the matrix. So procedure like this, when a problem is given like that, first you have to write let A is equal to the given matrix. A is equal to 1 1 2 4 2 0 1 4 2 2 4 8 3 3 6 12. So what you have to do is just reduce this matrix to upper triangular form. Upper triangular form means first you see what is the maximum possible square matrix. It is of order 4 by 4. That means is the square matrix and it is the diagonal of that square matrix. All the elements below the diagonal must be 0. But you have to use only that 3 operations mentioned. But in an order you have to proceed. So in order to make it upper triangular form, first what to do is you just make all the elements below the first element in the first column 0. Because the first column is here, this first element is 1, this 2, it is 2, it is 3. All these elements below this 1 must be zeros. So these zeros are made with respect to first row. Treating first row as the reference, all the elements of that column are made 0 by applying that operations, right, with respect to the first row. Say for example, you see, to make the element, first element in the second row 0, that means second element in the first row, first column, this must be 0. How to make 0? First you have to decide whether you are applying row operation or column operations. For our convenience, always you shall use row operations. Using row operations you can make this element 0. So to make this element 0, only 3 operations. You can add any 2 rows, you can multiply any row by a scalar, you can interchange any 2 rows. These are the 3 operations. Here you see this 2, the first element of the first row, if it is 2, 2 minus 2 becomes 0. So if it is 2, this minus this becomes 0. So how to make this one 2? So for this element only you can't multiply 2. The entire row must be multiplied by a constant. There is a one operation. So first row you can multiply 2 so that all the elements of first row are changed. Then if you subtract with the second row, this element becomes 0. So first mention the operation to be performed to make this element 0. What is the operation? In which row it lies? It lies in the second row. So operation for the second row, it is shown by putting an arrow mark. That means R2 is replaced by, how you replace? To make this one 0, R2, this must be 0. So that you write first minus, when it will become 0, this minus, it is multiplied by 2. 2 times R1. If you perform this operation, here 2, 0, 1, 4 is there. If you multiply by 2, it is 2, this is 2, it is 4, it is 8 you get. Then subtract it. What you get? So that matrix obtained is called equivalent matrix. We write like this. So if you use this symbol, the meaning is that not equal, it is equivalent. So the equivalent matrix we obtain is, write it, no operation for the first row. First row is as itself. What is that? 1, 1, 2, 4. How you replace the second row? This row minus 2 times the first row. So this 2 minus 2 times 1, that is 0. Next 0 minus, it is multiplied by 2. 0 minus 2 means we get minus 2. It is 1, it is multiplied by 2. So 1 minus 2 into 2, 4. 1 minus 4 means minus 3 we get. Next 4 minus, it is multiplied by 2. 4 minus 4 into 2 means 4 minus 8. 4 minus 8 means minus 4. That is the second row element. Next what to do? Next this element must be 0. That comes in the third row. Sorry, yes, third row. So operation to be performed for third row. With respect to that operation, this element must be 0. But with respect to the same first row, you have to make it 0. So mention here operation for third row. For the third row, it is R3 replaced by this also 2. The same operation because these two are on the same now. So for third row operation is same. R3 is replaced by R3 minus 2 times R1. So this row minus 2 times this row. So what you get? 2 minus 2 is also 0. And here 2 minus 2 is also 0 because it is multiplied by 2 throughout. Then 4, it is multiplied by 2. 4 minus 2 into 4, that is 0. Here 8 it is multiplied by 2. 8 minus 8, this also 0 I got. That is the operation for this row to make it 0. Next, which element you have to make 0? This one. First in this order you have to go. First, the first element in the, second element in the first column. The third element in the first column. Last element in the first column. Last element means 3. That comes under the last row. So operation for last row, what is the operation? R4. R4 is replaced by R4 minus, how will get this one 0? This is 3 here. With respect to first row only you have to make it 0, not with respect to any other row. So if you multiply the first row by 3, then 3 minus 3 becomes 0. So R4 minus 3 times R1 you can write. If you operate it, what you get? This row minus 3 times of the first row. This is 3. When it is multiplied by 3, what you get? It is 3, it is 3, it is 6, it is 12. So 3 minus 3, it is 0. Here 3 minus 3, this is also 0. Here 6, it is 6 here, 2 into 3. So it is 0. It is 12, it is multiplied by 3. So 12 minus 4 into 3, that also 0. Now you observe that whether it's reduced to upper triangle form, all the elements below the diagonal must be 0. Diagonal elements may be 0 also, right? Here all the elements 0 that are below the diagonal elements. What do you mean by that? It is the form where, that means upper triangular matrix. It is also called, the name for it is upper triangular matrix. Our aim is to reduce this one to upper triangular matrix. All the elements below the diagonals are 0. That condition is satisfied. If it is satisfied, see how many rows in this matrix? Non-zero rows. How many non-zero rows? First is non-zero row, second also non-zero row, but third is 0 row. All the elements are 0. Here also all the elements are zeros. So how many non-zero rows? Only 2. So that is the rank of this matrix. So rank of this matrix is equal to rank of matrix A. We write rank A is equal to number of non-zero rows here. How many non-zero rows are there? 2. So 2 is the rank of this matrix. Looking at the matrix itself, directly you can write number of independent rows. That is for objective question, immediately you can write. But if it is asked for 5 or 6 marks, you have to show the steps. How to show means just reduce this one to upper triangle form. If it is dependent row, when you apply that, that becomes 0. All the elements become 0. That means it is called 0 row. So this is the rank for this matrix.